Hello everyone. This is the video lecture for Calculus 1, Chapter Section 3.4. Chain Rule! So, let's do some cool derivatives here. We got derivative of f of g of x is equal to f prime of g of x times g prime of x. That is one of the biggest and best and most important formulas that you'll be doing for evers and evers. Right there. So chain rule means that you have a complicated inside. My inside is complicated. And so if that is the case, I'm going to take the derivative of it and multiply it on the outside. So let me give you a really basic example, and then we'll go out from there. Let's say I just got x squared. So I don't have a complicated inside, and you already know the answer is 2x. But let's just be silly for a second here. I'm going to say, okay, well, yes, to the 1 power, what's the derivative of x? Like on the side, I'm saying, hey, just what's the derivative of plain old x? And you're going to say 1. Reason why is because there's a 1 right in the front. You're looking for your slope, that kind of thing. There you go. Well, what's 2 times x to the 1 times 1 is, yes, it's 2x. So it does apply to all of what we've been doing, but a lot of times we could just forget about it and not have to do it. Okay, what about if I had this guy here? I said find the derivative. I don't need to have an equal sign there. I'm very sorry. It should be like an arrow thing because I'm taking a derivative. They're not equal. They're not equal. They're not equal. Okay, good. So the 2 comes down to the front, and I leave the inside alone. And then I say, hey, what's the derivative of the inside here? Again, it's just a 1, and so you don't really have to do anything, and it's basic. Basically what we've already been doing. But now let's change it up and do a 3x plus 1 all squared. Now I'm going to find the derivative. 2 comes down to the front. You leave the inside alone. Now it's a 1 power. But then you take the derivative of the inside, which would be a 3. What you now have is a 6 in the front. And again, I know you can simplify it at this point, but the point is that you have this additional derivative thing that you have to do when you have a complicated inside. This is the most simplistic example that I could think of. It will only get more difficult, starting here with question number 1. 0, 2, 4, here we go. So I got capital F of x is equal to 7x to the 6th plus 2x cubed all to the 4th power. I mean, look at this. This is the first one on your homework. I'm guessing. I don't really know. But like, it says, hey, figure out some chain rule stuff. Boom. And it gets worse. So let's try to figure this thing out. The 4 comes down to the front. You leave the inside alone. Leave the inside alone. Now that's the 3 power. But then, oh, I have a complicated inside. So now I've got to take the derivative of the inside, chain rule. 7 times 6 is 42. X to the 5th now. And then this 3 times 2 is going to be a 6. X squared now. And that is your answer. Do not simplify. You would be sitting there forever trying to simplify. Do not simplify. All right. F of theta is equal to cosine of theta squared. Find the derivative. Okay, so this one's kind of strange. We got cosine is going to go to negative sine. I mean, well, that's just what it is, right? I mean, you got a cosine, and it goes to negative sine. Oh, but wait, I got a complicated inside. And so I need to take the derivative of the inside there, and that would be a 2 theta. And you could put that out in the front if you like. Not required. So 2 theta, negative 2 theta sine of theta squared. And there you go. Cool. Okay. 34018. So I've got f of t is equal to 7t sine of pi t. Find the derivative. This is actually a product rule. Notice that we got f and g. And so I've got my f prime would be a 7. Then I leave the second one alone. Plus, and then I leave the first one alone. Now I have a derivative of second. So what's the derivative of sine? Is cosine. Oh, but wait, I have a complicated inside. So remember, what's the derivative of pi t is just going to be a pi. And that's your answer. I'm not going to box it. You could, of course, simplify this a little bit by taking the pi out to the front there. 3, 4, 0, 2, 3. So I've got y is equal to the square root of x over x plus 5. And notice that the square root is extended for every single piece of this problem. Okay, what do we do with this one? I'm going to tell you, let's just pause for a second. There's two different ways we approach this. I could split up the square root to both the top and the bottom, and then it would be a quotient rule very similar to what we've done in the previous sections. And it's actually something that we have done before. I'm not worried about it at all. But I want to try to use chain rule because that's the section we're in and we're trying to learn it. And so what I actually see this whole thing as is stuff all to the 1/2 power. So what's the derivative of stuff to the 1/2? Well, the 1/2 comes to the front. You leave your stuff alone, leave the inside alone, and then you minus 1 from the power. That's the basic normal derivative stuff. But we have a complicated inside. So now I've got to actually find a derivative of that inside, chain rule stuff, and figure this out here. This is a high, and this is a low. And so then we have low d high minus high d low, square what's below. So low d high, it's a 1, minus high d low, just it's going to be a 1 again. What's the derivative of that down there is a 1. And then divided by the square of what's below. Let's try to figure this out. These x's actually cancel one another, and the 5 can come down to the very, 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 very front. And I'm going to do some trickery, if that's okay. It's probably not okay. Just put that out in the front, too. You could just flip the inside of your square root, and somehow it's in the numerator now. I actually went further and canceled some more stuff. Oh, yeah. Yeah, I can keep going. I'm not one to simplify. You know this. But you could see this as x plus 5 to the 1/2 up there, and then just square root of x is fine. These right here can combine. So this is a positive half, and this is a -2, so it's a -3/2. I'm just going to put the square root x right here in the front now. And then what you actually have is this x plus 5 now to the 3/2. That's just another way to do it. Next question. All right, 3, 4, 0, 2, 5. I got y is equal to e to the tangent of theta. You might be wondering, when will I ever in the real world see e to the tangent of theta? Surely there's nothing out there that actually looks like that. You're right. Well, no, hold on. There is actually something that comes to mind. I can't say it's a direct correlation. I had this class called Complex Variables, and they were focused on like flow of fluids around corners and stuff. At least that was like a big portion of the class. And in order to do something like, and by fluids, I mean water or air, all kind of fluids out there, what they would use is these kind of, I guess, formulas, I don't know, forms. So e to the I theta, which that's a complex variable and all this other stuff, and that's cool. But you can see that it's e to a something is actually not unheard of, and this is engineering. So it's pretty in-depth engineering. I can't remember it all myself, but the point is that you see some of these weird ones, you're like, I'll never see this again. And you might not if you're going down a career path that doesn't really do intense engineering mathematics stuff, that's fine. But if you are, then I guess you will. And if you're interacting with those that are, then you will, at least somewhat. So moving on. Let's find the derivative of this and see what we can do here. Well, what's e to the x? What's the derivative of e to the x is e to the x, right? And so what I'm getting at is this doesn't change. You leave it all alone. Yay! Oh, but wait, there's a complicated inside. So I have to take the derivative of the inside, which in this case is tangent theta. Derivative of tangent is I'm waiting for it. Secant squared theta. Very good. 34030. We got f of z is equal to, oh, sorry, this is e to the z over z minus 6. This is an identical problem. So derivative of e to anything is, well, e to whatever, and then times now the derivative of the inside. So this is quotient rule, low d high minus high d low divided by the square of what's below. These z's will cancel. The negative 6 can come out if you like. There you go. And then you still have this EZ stuff like this. Cool. Okay, awesome. That was so fun. And so I don't know if I mentioned this before in some other video. I don't even know if you've seen my other videos. So I just, whenever it comes up in my mind and I see stuff, I want to talk about it. My perception of you as a student is that you're going to be moving on to Calculus 2. You might not be. I don't really know, but I'm just assuming that, and hopefully for a good point. So what I'm getting at is if there's better practices going forward in your math career, I say adopt them now early, and then that way it's easier when you keep growing up. This one in particular, that's Z. This is not Z. That's a 2. That's a 2. This is a Z. Stop doing that. Start doing this. I know a lot of people do the 7s like that. That's good. That's another point. Like if your 7s are sloppy, a little bit of line in there really helps the 7 kind of stand out. And so start adopting these kind of principles so that it's more legible for you and for other people as well. Because if you got like 2z and you're doing derivatives, well, I understand what's going on. Yeah, but like I don't. And eventually you might not. Just make sure that you can understand, what you're doing and practice now while you're still young. I guess is what I'm kind of getting at. Young in your math career. Or young at all, I don't really know. I got cotangent squared times sine theta. Okay, and apparently I know myself here that I did not give you the derivative of cotangent yet. And that's okay, because it's negative cosecant squared. And hey, what's the derivative of cosecant x? It's a negative cosecant cotangent x. This is very, very, very similar to the secant and tangent kind of configuration. The only difference is that there's a negative in the front, okay? So that's the only difference. Everything else should be the same kind of applying. One of those, two of those, all that kind of thing. So here we go. Let's find the derivative. So my derivative of cotangent squared is not on my list. What I should be seeing this as, though, is this guy. Okay, it's cotangent squared. That means there's two of them. Okay, this notation is better than this one, but that's just a pet peeve of mine. So now it's easy to take a whoa, 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 whoa. This is an incorrect statement. Uh-oh. Now it's a correct statement. That's a small particular as well. I often just say, oh, this equals, without doing the derivative. I don't know. Hey, we're actually taking a derivative now. It just happens. It happens to all of us. Okay. So now it's all to the 1 power. So you don't even have to write it like that. But see how I have a complicated inside? And so what's my derivative of cotangent is negative cosecant squared. But leave the inside alone. Oh, I have a complicated inside again. Derivative of sine is cosine. And that is your answer. You had to do chain rule twice. Wow, it's the first time, huh? Mark it down in your math history because, well, you're going to do it a lot. So, y is equal to e to the 6 e to the x. e to the x. Yeah, that one's a crazy one, of course. So I want to do my derivative, and so the derivative of e to the x is, guess what? It's e to the x. Sorry, here we go. Let's try that over again. There we go. But then I got to multiply by the derivative of the inside. What's the derivative of e to the x? Well, it's 6 e to the x. And that's it. Wow, that was not hard, I guess. It really is not. You're done. But sadly, they're wanting a second derivative of this as well. Now notice that this is going to be a product rule now, f and g. And so again, f prime g plus f g prime. And so then I've got e to the 6 e to the x, my derivative. And then I say, oh, but wait, it's chain rule. So then I actually have a 6 e to the x there. And then I multiply it by my g. So all of this here is my f prime, and that's my g. And then plus, I guess I could leave this one alone, finally. That's my f. And then my g prime, what's the derivative of this? Is itself. It doesn't actually change. That's your derivative, your second derivative. You can actually simplify this a little bit by moving out. Well, you can just combine like terms, I guess. Now, notice what I just did there. Did you see the 2x? Did you see that? It's pretty interesting, isn't it? Because you're multiplying your bases, you're going to be adding your powers. Because everything actually has an e base, what you could also do is some very silly math like this. And that is also okay. Yay! I think I maybe went a little too far there. We got 2 big problems coming up, and then I got 2 little problems, and then we're done. So we're getting close. 34059. It wants the equation of a tangent line. It's like every single section, you've got to have a tangent line, don't you? And their point is at 3 pi, 0. And we got the equation of sine of x. What does sine of x even look like, right? Well, go graph it and go check it out. I don't know what it looks like. It probably looks interesting. But we here are just trying to find derivatives and stuff, because what we have is a point. We don't know our slope. But once we have our slope, we should be good to go. So let's find our slope. That's be the derivative. Derivative of sine is going to be a cosine, but we leave the inside alone. Oh no, we got a complicated inside. The sine is going to be cosine again. And so we just get cosine of sine times cosine of x. And so what I want to do is, of course, plug in x equals 3 pi. So cosine of sine of 3 pi times cosine of 3 pi. And I really want to not mess this up. This guy right here actually equals 0, but that means that this guy right here is actually equal to 1. And the same thing with this is actually equal to a -1 of all things. And so what you got is a 1 times the -1 equals, well, -1. And that's my slope. I have my point, so y minus y1 is equal to m times x minus x1, 0, -1, x minus 3 pi. You don't need the 0, distribute, and so we get 3 pi minus x if you want to be fancy about it. You can flip them, of course, it's whatever. 34065. They say horizontal tangent lines. It's like we're doing the same problems again and again each time. As you know, this is y prime equals 0, so here we go. I got f of x is equal to 2 sine of x plus sine squared x, and then, well, find our derivative. Derivative of sine is going to be a plain old cosine. My equal signs don't look very good today. Any day, really. This right here is technically saying sine of x all squared, right? And so what's really going on is the 2 comes out of the front, I leave the inside alone, and now it's a 1 power. Oh, but wait, the inside was complicated, and so therefore we got derivative of sine is a cosine. And again, I'm trying to set this equal to 0, and so what we have then is 2 cosine of x plus 2 sine x cosine x is equal to 0. What I would do is I would factor this out, this 2 cosine business, out to the front. And so then you got 2 cosine of x times 1 plus sine x is equal to 0. Well, that means that my cosine is equal to 0, and my sine is equal to -1. Very good. Well, how do I make cosine equal to 0? Well, unit circle-wise, I'm talking about straight up and straight down. And so my x here is equal to pi over 2 or 3 pi over 2. Over here on my unit circle, I'm saying that my y value is a -1. So that's straight down, which is 3 pi over 2. Now, honestly, I still believe both are answers. Like, I know that we got the same one here, so, oh, well, that's my answer then, right? It's 3 pi over 2. Whoa, 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 whoa. This one still works also, okay? And so we have 2 answers. It's just that one of them got duplicated one time, okay? Also, if you remember how all this stuff works, you have to add the 2 pi n. Again. All right. And so these are my answers for where they happen, but they want the y values because WebAssign, of course, wants the y values. And so I'm just going to plug these in, honestly, into the original. And so that's the original, like the original. This guy right here, original. And so then I'm going to plug in pi over 2, which makes, hold on. Oh, pi over 2. Sorry, I was thinking pi over 0. Okay, we're good. Yeah, plug it into pi over 2, you get 2 times 1 plus 1 squared. And so you get 2 plus 1 is equal to 3. And then the same thing over here, it'll be a -1. So 2 times -1 plus -1 squared. -2 plus 1 is a -1, and that's going to be your y value. So my points, like my answers, what they're really wanting is pi over 2 plus 2 pi n, comma 3. And the other one is going to be 3 pi over 2 plus 2 pi n, comma -1. Now, how you put those in to WebAssign, I do not remember. That is something I'll just let you figure out. But I gave you the points. Do the formatting thing as they want. Okay, 34077. So I've got r of x is equal to f of g of h of x. Wow. And I think they give you this. I don't know. I'm just going to give it to you. How do you find the derivative of this? It's f prime of g of h of x. So you leave that all alone. But then you say derivative of this, you would have g prime of h of x. And then you say, what's the derivative of that? So you get h prime of x. Now, I can't remember if they gave you this or not. Maybe I'm just doing the math for you. I can't remember, but that's what you're doing. It's triple chain rule-y stuff. So they do give you these points, though. Let me try to put them all in here because this is what they want. And then we can hopefully, that's supposed to be an F. I wouldn't say my Fs are the best looking. Okay. And so now they want to find r prime at 1. What? I'm just going to basically start plugging it in, starting over here. That's going to be a 4. And then this guy here is going to be a 2. And so that's going to be a 2. And g of 2 is a 3. So we got f prime of 3 times g prime at 2 times 2 Well, we have this guy as a 7. G prime is a 4, and that's a 2. And hold on. Somehow I messed up. How is that? Oh, this is not a 2. This is a 4. Sorry. It's right there. It's a good thing I got my notes so I can double check myself. And so I got 112, and there you go. If you just basically look right here, here, and here, right? So you got these guys right there. You multiply them, and, well, there you go. All right. 3, 4, 0, 8, 5. I've got s of t, which is typically a position function, is equal to 4 plus 1 over 5 sine of 4 pi t. And then they want the velocity, which is s prime. That would be a 0 plus 1/5. Derivative of sine is a cosine. Leave the inside alone. Derivative of cosine is going to be a negative. I'm sorry, whoa. We just did that. Hold on. Don't do chain rule like that. See, I was going too fast. I was assuming too much. Okay, moving on. Derivative of the inside. We already did the sine goes to cosine. Derivative of the inside is just going to be a 4 pi. And so my answer here is 4 pi over 5 cosine of 4 pi t. Okay. And that's all I got. Whew. All right. We're done. The next section is super fun. Seriously, it's like one of my favorites. So thank you very much. Have a great day.